back with another video, and today is nothing too complex. Today is just a little fun circuit and purely analog circuit. So yeah, just getting out of the power and microcontrollers. It's nice once in a while to go back to the good old circuits. So yeah, this is one of the famous ones. It's called the LED chaser, and it basically uses our good known friend the 555, and the another IC here, which is the CD4017, which is a Johnson decade counter. So yeah, it uses these two in a cascaded form, and you can put these 10 LEDs, and according how many ever number you want, but 10 is the max. You can even go lower than that. But yeah, it basically uses this 555 in a astable config, astable multivibrator. So it's going to generate continuous clock pulses at a decided frequency depending on your R1, R2, and C values. And that clock, with basically the output of that, is going to go to the clock input of this decade counter. And every time the clock goes, to the positive edge, the one of these inputs is going to roll over, and the next one is going to turn on. So basically, once one clock pulse comes, Q0 turns on, and this LED lights up. Then after that, after the next clock pulse comes, that one turns off, Q1 turns on, and so on and so forth. So basically, in order, this all of these are going to turn on, and after Q9, which is the 10th output, it's going to roll over and go back to Q0. So that's why it's basically a decade counter, you could say. So if you make it fast enough, the frequency of this, it looks like the LEDs are like chasing each other, so hence the name LED chaser. They're gonna turn on one after the other. So yeah, this is the circuit, and there's nothing to explain much here. This is the R1 value, R2, and the frequency, I think I decided it to be the time period for it to be maybe around 300 millisecond to 1.5 second, if I'm not wrong. So yeah, between that, and that's why, as you can see, there's a pot here to vary that speed. Otherwise, it would be a fixed speed. So yeah, and these are the LEDs. That's the 4017, and that's the 555, and I'm powering the entire thing using a 9 volt, and that's totally fine because the 555, it can take up to 18 volts, so that's good. And also the CD407, in the as the name suggests, it's the CD, which is the CMOS series, and that's known for having the wide range of input voltage, VCC. So again, this can take up to 18 if I'm not wrong. So yeah, 9 volt should be fine. However, if you were using the 74, the TTL family, you would have to power this using 5 volts, because that is very tight. You cannot exceed that, or the IC gets damaged. So yeah, this is CD, so it should be fine. So yeah, now let's just go to the demo. So yeah, just a small setup on a single breadboard here, and yeah, a lot of wires, but yeah, already I don't really need to explain it. Just to connect all the LEDs. That's mainly why there are so many wires. But yeah, there's the 555 in there, and yeah, there's our pot. To vary the speed. Just a small 10K trim pot here, and yeah, those are the LEDs. And yeah, I picked out all the LEDs, every single color which I could find. So we have pink, blue, white, green, yellow, orange, and I think a darker orange, a red, and then yeah, blue and pink to repeat with. So yeah, and it just looks nice, all the colors. So, and all of them have a series current limiting resistor, and I realized this later. You can see here I'm using 10 different resistors, all are 470, but you don't actually need 10 resistors. One should be enough, because as I showed in the circuit diagram, only one of these LEDs is going to be on at each point. So one resistor is enough, but I realized it that a bit too late. So yeah, I didn't bother removing them. But yeah, just one resistor should be enough. You can short all the cathodes together and give it to ground, and yeah, a single resistor. But yeah, again, doing that on a breadboard would have been a little weird again. So this should be fine. And yeah, I'm powering it all using this single 9 volt battery here, as I said, and just a small SPST switch to yeah, just give a good presentation. So yeah, let's press this button and start the demo. So yeah, it looks like it has started, and currently it's on the lowest speed, if I'm not wrong. So you can see it's on on it's moving, and it seems slow, maybe 1 second or something. So we could speed it up. We have the pot here, that's exactly where I put the pot. So let's speed it up a little bit, going clockwise. And yeah, you can see now it has become faster than before, but it's still not quite fast. But yeah, you get the point. It rolls over. So now let's just go to, to the max speed. Let's see how much how fast it can go. So yeah, I've reached the maximum, and you can see this is what proper chasing looks like. It seems like they're running behind each other. So yeah, that's all for this demo. I hope you liked it, and yeah, thank you.